Hey guys, today we are looking at 6.6 notes, which is all about arithmetic and geometric sequences. A sequence is an ordered list of numbers. We talked about that with a gizmo that we were working on yesterday. But today we're looking specifically at arithmetic versus geometric sequences when we have one or the other, and then making some predictions of subsequent terms after we know what kind of sequence it is. So like I said, a sequence is an ordered list of numbers, but specifically an arithmetic sequence. I know that looks like arithmetic. It's pronounced arithmetic. An arithmetic sequence is an ordered list of numbers where we have a common difference between my terms. Meaning, as we go from one term to the next, there is something that I can add or subtract in order to get my next term in that list. And it has to be consistent. What works for the first term to the second term has to also work from the second to the third and the third to the fourth. For however many terms you see in your sequence, you have to make sure that that common difference is consistent. Sometimes you'll be asked to identify what the common difference is. For the most part, it's just going to be identifying when a sequence is arithmetic and then making some predictions of other ones. But if you're trying to find the common difference, if it's not apparent to you what that addition or subtraction is, you have this little formula to be able to figure it out, where if you want to know what the common difference is, which we use D for that abbreviation for common difference, you're just going to take some term and subtract the previous term from it. So if you couldn't identify that plus 4 was our common difference here in this sequence, I could take 13 and subtract the previous term, which would be 9. That's the term that came right before it. And we would end up at positive 4. And we'd be able to say, hey, my common difference is 4 based on my formula here. So that's arithmetic sequences. Common difference, meaning we can either add or subtract from one to the next. So in box 2 here, we're looking at geometric sequences. Geometric sequence, still an ordered list of numbers, but here, instead of having a common difference, we have a common ratio, meaning there's a common multiplier that gets from one to the next in my sequence. Now that could look like a multiplication where our numbers are growing. That would be our multiplier bigger than 1. Or it could be a multiplier that's a fraction or smaller than 1, and it looks like a division. Both of those we know are the same thing, just like with our exponentials. So what I'm doing here, I'm trying to identify if it's geometric. That means there should be a common multiplier to get from one to the next in my sequence. Here, getting from 1 times 5 gives me 5. 5 times 5 gives me 25. Times 5 gives me 125. So we can see that that common ratio, my R value, would be positive 5. Again, I have that shortcut here, that formula. If it's not apparent to you what the multiplier is, which these ones, sometimes they might be a little bit confusing. Maybe it's a decimal or a fraction that our multiplier is, and it's not apparent. It's not easy to see what that pattern is. You can do division of a term divided by the previous term to figure out what that multiplier is. So I could take here 125 divided by the previous term, which is 25, and I would get what my common ratio is, what that multiplier is with positive 5. All right, most of what we'll have to do in box 3, we're identifying sequences. So here, what my instructions would be identify if the sequence is arithmetic, geometric, or neither. So here we're given a sequence of numbers. We're trying to figure out what the pattern is. If that pattern is addition or subtraction, that means it's an arithmetic sequence. If that pattern is multiplication or division, it's geometric. If it's none of those, if it isn't multiplication, division, addition, or subtraction, that's a neither situation. So I always just look at which one is the most obvious to us and just trying to figure out how can I get from one to the next in my first term. So for number 1 here, our sequence is 120, 60, 30, 15. So to get from one to the next in my sequence, if I thought that it was arithmetic, to get from 120 down to 60, I have to subtract 60. But here, to get from 60 to 30, I'm only subtracting 30. So I know it's not arithmetic. I know there's not a common difference to get me from one to the next in my sequence. What is the case here, and what I can do to get from 120 to 60 would be dividing by 2 or multiplying by half, depending on your personal preferences. And we're going to check and see, does that also work for the rest of my terms? To get from 60 down to 30, that is also a half. Half of 30 is 15. Oops, I started writing 15. So I see that I can divide by 2, or, could also say this is times a half if you wanted to have it be a multiplication. Either way, we see that there is a common ratio between my terms, that ratio being a half. So we would be able to conclude here that number 1 is geometric. It is a geometric sequence because we have that common ratio. We have that multiplier to get from one to the next. With number 2, our sequence is 2, 6, 11, 17. So if we thought it was arithmetic, we would look at what I would have to add or subtract to get from one to the next. So 2 up to 6, that's not 4. Yeah, it is 4. 6 up to 11 is 5. 11 up to 17, I'm adding 6. So even though there's a pattern to my sequence, there's a pattern to those numbers, in this case, there's not an addition or subtraction that works nicely. So it's definitely not arithmetic. If I did the same thing, I'm just going to use red up top. To get from 2 to 6 using multiplication, that would be times 3. And then if we do times 3 here, we know it's not going to work to get from 6 to 11. 6 times 3 is 18, not 11. So in this case, it's actually neither. Neither. Okay. Number 3, here we have our sequence is 3, negative 12, 48, negative 192. So I know we talked about this in the gizmo, but the thing that you should pick up on that's a little more unique than we're used to seeing, we have an alternation of signs. We're going back and forth between positives and negatives. So right off the bat, that should eliminate arithmetic for us, because if we're adding the same thing or subtracting the same thing, our signs are not going to be flip-flopping back and forth. So we're just checking to see if there's a consistent multiplier to be geometric, which in this case, to get from 3 to 12, that would be multiplying by 4. And to switch the sign, we have to multiply by a negative 4. So we think our multiplier is negative 4. What we have to then verify is that still works for the rest of my terms. If we do negative 4 times negative 12, that does give us positive 48. Positive 48 times negative 4 does give us negative 192. So in this case, it does work. It is consistent. It is geometric. If you wanted to, you could say R is negative 4. You don't have to, but here, that helps. All right, so for number 4 here, our very last one, our sequence is 1, 4, 7, 10. So we're going to check and see if it's arithmetic first. That's just where I usually start. Here my numbers are growing small, and I don't see a pattern for multiplication. That's just what my brain sees. So we're just going to check and see if there is a constant addition or subtraction that works in my sequence. So to get from 1 up to 4, I would have to add 3. 4 plus 3 is 7. 7 plus 3 is 10. So this one is arithmetic. My common difference here is positive 3. All right, our very last one here. All right, so for box 4, we are finding terms. Now this question format is exactly the same as one of the problems that will be on your test. Is a little bit different, so I want to make sure I went through one of these with you. So number 5 says that we have the first two terms of a sequence are our A1, which is our first term, is 12, and A2, which is our second term, is negative 6. If we let A3 be the third term when the sequence is arithmetic, and B3 be the sequence or the third term when the sequence is geometric, they want us to find A3 plus B3. So what that translates to, we've got two different options. We're gonna label. We'll do arithmetic in blue, and we're gonna do geometric in red, because they're wanting us to continue this pattern in two different ways. The first one, my sequence is 12, negative 6, A3, and that's where it's arithmetic, where there's a common difference. And then for the geometric side of things, first two terms are the same for -6, but then they want us to find B3, where the third term of my sequence from a geometric. So starting with our arithmetic side of things, if it's arithmetic, remember that means we have an addition or a subtraction to get from one to the next in my sequence. So to go from 12 down to -6, we would have to subtract 18. 12 minus 18 would give me -6. So that means that A3 I would find by subtracting 18 from -6. So we should get that A3 is -24. Oops, A3. Okay, continuing the pattern for my geometric sequence for B3. If my sequence is still 12, -6, but with a geometric, we know that that means there's a common ratio, a common multiplier to get me from one to the next. To get from 12 to -6, I would have to divide by -2. Right? 12 divided by 2 is 6. To switch my sign, I'd have to have it be a negative. So that means my B3, I would have to divide by -2 to get B3. So -6 divided by -2 is a +3. Half of 6 is 3, and then my negative flip-flops back to a positive. Now, the answer here is not just those two separate things. They want us to find what A3 plus B3 is. So whoops, I forgot to label that up there. This is B3, our third term. So A3 plus B3 is -24 plus 3, which would be -21. So it's a little bit weird format-wise in terms of like using our what we call our sequence notation, A sub n, A sub 1, A sub 2, A sub 3, B sub 3, that kind of notation. But when you look at the actual thing that you have to do, we're taking a number, the first two terms, make a third prediction. If it's arithmetic, same thing with the geometric, and then just add those two numbers together. All right, that's all I got for you guys. Homework is right there at the top, page 336, 3 through 14, and 19 through 24 all. On 19 through 24, don't graph. You're just making a prediction for the next terms of the sequence. That's all I got for you guys. So as always, if you have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.